This video is part 2 of my circuit analysis example number 1. We're going to start here where we left off from part 1 of this example. In part 1, we developed the equations that we'll use to solve for the potential difference across each resistor and the current through each resistor. In this part, we're going to actually perform the calculations. Normally, I like to wait to the very end of the algebra manipulations to actually put numbers into my equations, but in this case, the equations get pretty gnarly. So I'm going to put the numbers in a little bit earlier than I normally do. It will simplify what I need to write, which is good because I'm running out of space on the screen, but it will also actually prevent us from making mistakes. So I would like to use 3 particular equations that we developed in part 1 in order to simultaneously solve them, or solve and substitute, to answer this question. The first equation comes from the third loop that we analyzed in part 1. It relates the voltage drop across resistor 2, I2R2, and the voltage drop across resistor 3, I3 times R3. The second equation comes from the analysis using Kirchhoff's current law, that the sum of current 1 and current 2 equals current 3. The third equation we're going to use is a voltage law equation. It came from analyzing loop 1. That the EMF of the battery minus the voltage drop across resistor 1 plus the voltage drop across resistor 2 all add up to 0. Start with the equation from loop 3, put in the values of the resistors, and then solve this equation for I2. You should find that the current through resistor 2 equals the negative value of the current through resistor 3 times the number 0.75. I strongly recommend that you pause the video and check that you can get this same equation. Next, I substituted the current law equation in for I3. My final equation uses the analysis of the voltage law on the first loop to substitute in for the current through resistor 1. It's very important that you understand where this substitution comes from, so you may want to pause the video and check that you understand. Next, you can take the numerical values and simplify this equation. The 12 volts is divided by 100 ohms and then multiplied by 0.75 to get 0.09 amps. 200 ohms divided by 100 ohms times 0.75 is added to 0.75 times I2. We factor out the I2 and get I2 times 2.25. Check these steps and make sure that you can get the same numbers. Now you combine the like terms, the I2s, and solve for the value of the current through resistor 2. You should find that the current through resistor 2 is negative 0.0277 amps. That's with 3 significant figures. This negative sign indicates that the direction we chose for I2 is not the correct direction of the current. This is not considered to be a mistake. This is not something that you would lose points for, and that's why you don't need to worry about your choice of direction for current. If you happen to pick the wrong direction, you'll be signaled that later in your algebra when you get a negative value for current. Keep the 3 significant figure value of I2 for using in later calculations, but report your final answer for the current through resistor 2 to 2 significant figures, negative 0.028 amps. And then we will carry that on and use it to help us solve for the rest of the currents through the other 2 resistors as well as the voltages across each resistor. Use Ohm's law, V equals IR, to solve for the potential difference across resistor 2. Use 200 ohms for R2 and the value you found for I2 to find that the voltage difference across resistor 2 is 5.5 volts. Don't worry about including a sign. The direction of going across the resistor isn't important. From analyzing loop 2 that has only the 2 resistors in it and no battery, you know that the potential difference across resistor 2 has to be equal in magnitude to the potential difference across resistor 3. So now that we know V2, you also know V3. From Ohm's law, we know that the current through resistor 3 equals the potential difference across resistor 3 divided by its resistance, 150 ohms. Put in the values and solve for the current through resistor 3. The current through resistor 3 turns out to be 0.037 amps. That's rounded to 2 significant figures. Now we just need to find the current through resistor 1 and the potential difference across resistor 1. We have enough information to solve for either one of those things right now. Let's begin with the current. The way that I've drawn my circuit, the current through resistor 1 equals the current through resistor 3 minus the current through resistor 2. Remember when we solved for the current through resistor 2, we got a negative value. You need to keep that negative sign so that we will have the current through resistor 3, 0.037 amps, minus a negative 0.028 amps. The result is that the current through resistor 1 equals 0.065 amps. Finally, use Ohm's law to solve for the potential difference across resistor 1, and the result is 6.5 volts. We have found all the values that the problem asked us to find, the potential difference across each resistor and the current through each resistor. So this is the end of the circuit analysis example 1.